gap.
Thanks, Dr. Case. Like you said, I'll be talking about higher education and the gender gap. So, as you might know, today about 60% of all U.S. bachelor's degrees are being awarded to women. Some people are calling this the reverse gender gap. Despite this, the National Center for Education Statistics reports that only about 36% of all STEM degrees are being awarded to women. So today we're going to dig a little bit deeper into this statistic and talk about where that disparity might come from. One common critique when asking questions around this topic is that we might use the STEM umbrella a little too broadly. What we'll see today is that there are wide differences in the gender gaps between specific STEM fields. For example, if you want to talk about the gender gap in the STEM field of engineering, that needs to be a vastly different conversation than the conversation about the gender gap in the STEM field of health, for instance. So, as we do this, we're going to keep 3 questions in mind throughout the entire presentation. Where did we start, where are we now, and where are we going? In other words, we're going to take a historical look at how women have been represented in STEM fields in the past. We're going to assess kind of the current status of where that is, and we're going to keep an eye towards the future to think about where these trends might be going. So to do that, we're going to start by talking about our methodology, specifically how we might answer that third question of what might happen in the future. And then we'll talk about trends in specific fields. As I alluded to, it's important to distinguish between STEM fields, so we'll break this down into 8 different types of STEM fields and go from there. After we've done that, we'll do some comparisons across fields and degree levels. And when I say degree levels, I'm talking about bachelor's versus master's versus doctor's degrees. We'll see that those kind of all have their own trends. And then we'll compare across that another time. And then at the end, I'll wrap it up with what I think the future work should be and what the open questions are, and we will finish this from there. So first, we're going to talk about how to make predictions about what's going to happen next. So if you've taken advanced stats, you've definitely heard the phrase time series analysis. If not, all you need to know is that time series analysis has to do with the collection of methods that we use to take historical data and predict the future from it. So one really important type of time series analysis is called exponential smoothing. And what exponential smoothing does is it places more weight on the most recent historical points. So in our context, we're going to be looking at data that spans from the 1970s through about 2018. So more weight is going to be placed on the data points from the 2010s than will be from the data points from the 1970s, which I think makes sense when you're putting an eye towards the future. The other 2 things that we want to keep in mind when talking about which type of exponential smoothing we want to use are whether or not we expect trends and seasonality. So the trend has to do with the overarching direction of where a field might be going or where a statistic seems to be headed, where its overall arc, where seasonal patterns have to do with repeatable fixed periods of time where we expect certain types of patterns to emerge. For instance, if something happens every day or once a year or once a month, that type of thing. So for our purposes, we're going to focus on double exponential smoothing because we are looking for trends. That's kind of our whole goal. But we really don't expect seasonal patterns when we're talking about the proportion of women earning STEM degrees. So now that we know what we're going to do, let's talk about some trends in specific fields. Like I said, we're going to be looking at 8 different categories of STEM fields. Don't worry, you don't have to memorize these, but I want you to keep them in the back of your mind as we work through our presentation. So these are 8 categories of STEM fields based upon the way that the National Center for Education Statistics aggregates their data. And they're classified as STEM fields based upon the National Science Foundation's definition of STEM. So we're going to keep these in mind as we look at these 8 fields at their 3 different degree levels. So 8 fields, 3 degree levels. All in all, we're going to have 24 types of STEM degrees where we're going to be forecasting into the future. So with that in mind, I did 24 different time series analyses. And don't worry, I won't show you all 24 graphs, but I did want to look at 2 extreme examples and 1 interesting one. So let's look at our first forecast. One thing I want you to notice right away is this horizontal line. We'll see it in every graph that we look at today. And this is just where we would be if 50% of degrees in this field were being earned by women. So right now we're looking at doctor's degrees in engineering. And you'll notice we're nowhere near this. Like I said, I'm showing you extreme examples, so this is one on the extremely low end of the scale. But from 1970 to 2018, we have our historical data about the proportion of women, or the proportion of these degrees being awarded to women. In every graph, our key metric is the proportion of degrees in that field being awarded to women. So we have historical data from 1970 to 2018, and then from 2019 to 2030, we have our projected data based on what we found using the double exponential smoothing. And this gray area here is just our 95% confidence interval for that forecast. So, like I said, these are doctor's degrees in engineering, and one thing that we see in this graph is that even though in 1970 less than 5% of these degrees were going to women, we do see this constant increase through 2018, where about 25% of degrees are now going to women. And over the next 10 years or so, we see that even at the low end of our confidence interval, we expect that trend to continue. So that seems kind of encouraging. Moving on, like I said, I want to show you two extremes. So take a good look at this as we flip to this example. And I hope now you're starting to see why we have to talk about STEM fields in their specific fields and not just STEM overall. So these are master's degrees in the health field. And just like before, we have our 50% line, but it's almost obliterated by the data. So ever since 1971, where we start, all the way through all of our historical data and all of our forecasted points, we have seen and expect to continue to see women earning the majority of degrees in this field. So those are kind of the two extremes of what we're looking at. Like I said, I won't show you all 24 plots, but I want to show you one more that I think is really interesting. So what you're seeing now are bachelor's degrees in computer science. Out of all 24 analyses that I did, this is the only one that looked anything like this, and let me explain what I mean. From 1971, when our data starts, through about the early to mid-1980s, we see an increase in the proportion of these degrees going to women. However, from the 1980s through just about present day, there's a pretty steady decline. This is the only plot out of all 24 that I saw where there was an increase and then a decrease. Most plots have either had pretty constant increase or an increase and then some leveling out. This is interesting based upon the fact that it was going up and now it's declining. We do see around 2015 that there might be a slight uptick, but in general, it's really hard to predict what's going to happen in this field because it's been so confusing in the past. And we see that in our forecast too. Within our 95% confidence interval, we see that there is a chance that by 2030, more than half of the degrees in this field will be earned by women. But we also see by 2030 that, at least based on what we found with our double exponential smoothing, that negative of the degrees will go to women, which is obviously not possible in reality. But even the fact that that showed up in the mathematical calculations, I think really makes the point that this is a very volatile field, and we don't know what to expect from it because it's just so random and different from all the others. So I think you could do an entire presentation just on this slide, but unfortunately we have to move on. Because I think even more interesting than just looking at the specific fields is comparing the fields to each other. And so that's what we're going to do next. But before we do that, I want you to remember the three questions that we asked ourselves at the beginning. And when we were looking at the specific fields, it was easy enough to talk about every single year or to visualize every single year for all the data that we have. But that gets more messy when we look at all the fields and all the degree levels. So we're going to think about these questions when we talk about the rest of our data. Where have we been, where are we now, and where are we going? And so for these purposes, we're going to look at 3 representative years for the rest of our data. 1971 would be our historical point of reference, since that's the earliest year where we have data in all the relevant data sets. 2018 is going to be our present day point of reference. And I know you're thinking, but Ariel, 2018 was so 2 years ago. And I know, but it is the most recent year for which the NCS has released data on this. So that's what we're going to go with, and I think we can all agree that it was recent enough that probably not too much has changed. And then finally, with an eye towards the future, we're going to use 2030 as our anchor point for what we're forecasting into the future. So let's look at our first graph that compares across degree levels. So here, just like before, we see this 50% line of where 50% of women would be earning degrees. Notice that this is only data from 1971, so it shouldn't be too surprising to you that almost every field is well below this line. Across the bottom here, we can see what the different STEM fields that we're looking at are, and we can also see that each has 3 bars corresponding to either bachelor's, master's, or doctor's degrees. Like I said before, I wanted to show you the 2 extremes, and you'll notice them here again as we see engineering with almost no female representation in 1971 compared to the health fields where, at least at the bachelor's and master's levels, are completely dominated by women. One thing that's kind of interesting about this graph is the difference between the number of women earning doctor's degrees and the number of women earning bachelor's and master's. Even in the health fields, where women have such a large representation at the bachelor's and master's level, there's a sharp decline to the doctors, where doctor's degrees in health fields really aren't representing more women than any of the other degrees that aren't doing as well at the earlier degree levels. So even though the difference is kind of the most stark contrast in the health fields, we do see this continue through all the other fields. So that is one thing to keep in mind when looking at this. And another thing that I want you to notice now, because it's going to come back later, is kind of which degrees are on the left side of this chart and which degrees are on the right side of this chart. So you might have noticed that these are approximately ordered in the order of least female representation to most female representation. And what we'll find is that on the left side of that, we have engineering, computer science, physics, and math with the least amount of representation. And on the right, we have bio, social sciences, psychology, and the health fields. And even though right now, there might not look like there's much of a difference between math and biology, as we move forward into present day and in the future, the difference between these two groups will only begin to grow. So this is 1971, and let's take a look into what the 2018 graph looks like. So that was huge, right? I'm going to do that again. 1971 to present day. That was a lot of growth that was really immediately visible, and I think that we can be really encouraged by that. So we see now, with our four groups that are on the right side of our graph, at least at the bachelor's and master's level, at least 50% of the degrees in these top four STEM fields are now being awarded to women. And even though there is still a bit of a drop-off when you get to the doctor's level, that disparity has decreased drastically, especially in something like the health fields, where it used to be ginormous. You might notice that psychology is now a bit more represented by females than the health fields, but in general, a lot of the ordering of our fields hasn't really changed over time, which is also kind of interesting. So I'd love to spend more time on this, but we can't. So moving on, we'll do one more graph in this section for our future projected degrees. One thing to keep in mind when looking at this is that what we're seeing here are just the average expected values for female representation in this field. And unlike the earlier graphs where we were looking at confidence intervals, we had to take only the average or else the graph was just a little too busy. So just like any time that we're predicting the future, it's important to keep in mind that we do expect some variation in what will actually happen, different from what we have here. But this still has a pretty good idea of what we might see. And just like before, we see social sciences, biology, health fields, and psychology being the only ones that tend to have more than 50% female representation. So as I was looking at those three graphs, what I realized is that I kept flipping between them really quickly, trying to see what had changed. I started in 1971, and I flipped to 2018, and then 2030 real fast, because I wanted to see what was growing over time. And so I thought to myself, why not actually make a graph that shows that? So for the next three graphs, instead of looking at one for each time period that we're considering, we're going to look at one graph for each level of degree. So let's start by looking at the bachelor's degrees over time. So this is kind of a new type of graph here, but it definitely helps us compare the degrees to each other over time. So just like before, we have our 50% line for where we would be if 50% of the degrees in these fields were being awarded to women. And then on the far left here, we have our historical 1971 data points. Here in the middle towards the right kind of, we have our present day 2018 data, and then all the way on the right, we have our 2030 data. So this graph is definitely something that helps us see how things have changed over time. And I think in general, this is another point where we can be really encouraged because we see pretty consistent growth. And take something like psychology, for instance. When looking at the previous graphs, it might have looked like psychology grew a ton from 1971 to 2018, but not that much from 2018 to what we expect in the future. But if we actually look at the slope of psychology here, given that we're now spacing it out appropriately over time, we can see that there's been and is expected to continue to be a pretty constant rate of growth in psychology. So almost every field is growing, which I think is pretty encouraging, other than math, which seems to be a more consistent level, at least from historically to present day, has only grown a little bit, and moving into the future is expected to stay pretty similar or even drop a little bit. But all of the other fields are growing a lot, which seems to be pretty encouraging. The only other thing that I want to point out here is that our groups of 4 and 4 have kind of stayed the same. So everything from social sciences, biology, and the health fields and psychology are at least at or above equal representation in the present and future day. Whereas you could call these our newer majors, the physics, math, computer science, and engineering are still kind of lagging behind. So these are the bachelor's degrees. I'm going to flip over to the master's degrees here. And what you're going to see is that the 50% line is still a pretty decent cutoff to separate our newer majors from the rest. Definitely, there's some variation within those two groups if we want to talk about it like that. But in general, I think there are some clear trends here about where there's underrepresentation versus not. So the only other thing that's really notable about this graph is that pretty much all the degrees in the master's field seem to have increasing representations of women, which I think is pretty encouraging. So finally, we'll look at one more graph, which is our doctor's degrees. And if you've been paying attention to the last two graphs, you might notice immediately that overall these values are lower, which kind of tracks with what we saw previously. And more than ever, I think this gap between our underrepresented fields is very pronounced compared to psychology, health fields, biology, and social sciences, where even though social sciences might not be at that 50% threshold at the doctor's level, they are still doing much more closely to that equal representation than these 4 majors down here. And it's also interesting to note how in 1971 they were kind of all mixed together as they all had pretty terrible representation. But as we moved into time, in general, most things have increased, and these psychology, health fields, biology have increased so much that they're not really at the points where we consider them underrepresented anymore. So we've talked a lot today about some of the statistics and trends that we've seen, but there's definitely a lot of work to be done. For instance, even just in the computer science realm, like what happened there, what was going on with that graph, what happened in the 80s where it went from women being increasingly represented to decreasingly so. We can also look into more about why there's such a disparity between where we are with like the math and the physics and the engineering compared to the health sciences and the bio and the psych, and look more at that disparity and why that exists and what we can do to encourage growth in those areas. But I think one of the biggest things to take away from this is that if we want to have conversations about these topics, we need to be looking at specific STEM fields and not STEM as a whole. So these are my references, and does anybody have any questions?
Did you see what specific careers would have been covered under the